Welcome everyone. Today we are going to go on another live session to teach you about how to work with data from the Federal Reserve. If you go to their website, we can see that we have got many topics to search from. For example, the inflation, and here we get many indicators ready to be analyzed. If we click in one of them, we will see the time series from the first very moment when it was recorded. In this case, for the CPI, inflation, we got data from the year 1968 until nowadays. The key thing is how we download this data and pre-process it with Python so that we can combine them with other data sets, other indicators, and create a multivariate analysis. We have been doing these live streams for last year. We recorded at least 7 episodes, which you can review here in this channel, Datons Stories, Coding Stories with Data. Topics from time series, energy from the US API, the Energy Information Administration, also from the stock markets, backtesting, a Python library to develop algorithmic trading strategies and backtest them, Alpaca API, exchange, a, a platform where you can register and with a demo account, you can trade in the stock market using Python code, which is good to practice. And in this series, if I want them to be interactive, so I will take your questions as a priority. I will develop the practical case related to the topic with ChatGPT. I will do a little bit of vibe coding to go directly to the point and analyze which are the best indicators to relate so that we can build a cool practical case that you can use to learn these skills. Having said this, I will pay more attention to your questions. So if you have any, leave them in the comments and I will address them with the codes because this is question and codes. You make an question and then I will answer it while developing the code. So I want to be this really interactive and show you many tricks that you can learn with Python and get ready with it. So let's get started. After this live streaming, I will be posting the related articles with Python codes in this website, stories.datons.ai. You can see that we have already covered some of them. If I go to any, you can see what you will develop, loading some data set, answering these questions with the Python codes, etc. All right, let's get to it. The first thing we do is opening the editor of codes, that in this case is Visual Studio. There we have it. I have created a folder to work with this practical case. Let me close it so that you can learn the process. Also, if you have got any questions related to how working with these programs whatsoever, feel free to drop it in the comments and I will prioritize them to address it in the moment or at the end of this live event. So whenever you want to work with Python codes, you open the editor of code, that in this case is Visual Studio, and then you will have a folder to be working with these programs. In our case, let me open it. There we have it. I mean, you can even create, if you're working on your own, create here a new folder. And once you have created it, you can drag and drop into Visual Studio Code. And there you have the files if you had any. But in our case, we'll work with a file that is blank from the very beginning. So let me put it here. Let's put the name like script. And there we are, ready to code. Now, to give you a perspective on what we might address today, is that when we download data from the Federal Reserve, sometimes the information doesn't have the same properties. What does this mean? For example, if I download the inflation and then another time series, which is the mortgage rate, you can observe that the frequency coming from the index, in this case from the CPI, the inflation, it's monthly. And for the mortgage rates, we see a weekly frequency. This is from the 2nd of the 4th month until the 9th. So it's just 1 week. However, in this case, is from January to February, 1 month. So by the time that we join the data, we see that there are problems like the missing information because we don't have weekly information on the inflation. That's why we get missing values. NANN means not a number because there is no information. However, for the mortgage rate, that is a weekly indicator, we have it. And the questions here is, what are we going to do? Because there are many things we can do with time series data. Let me show you here some examples, in this case with a data from the Energy Administration. That's because of the temporal properties, we can visualize the information to tell a story. In this case, the story is regarding with time series data of energy. That's the most impactful is, for example, solar energy. This is the total energy generation, real data from California. We observe that in this case, during the summer months, we've got more energy generated than during the winter months. As we see, January 3, but during the summer we get 7.88. This is in gigawatts per hour. So we create a ranking also to see which are the technologies that generate the most energy in the US, in California. And in this case, they say that the first one is natural gas, seconded by solar, then hydro energy, then there is the average, wind, nuclear, other, coal, and finally petroleum. So charts like this we can develop with the Python code because we have the time properties. Let me take a sip of water. All right. So how are we gonna download this information? Because whenever I develop any practical case, I have a template that is first output. What do I want to do? Then I have the inputs from where do I start. Then I have the context, although the context can be at the very beginning, which is what I have already told you, sort of. And finally, the most important is the steps. What are we going to do? To go from the inputs to the outputs. And in the outputs, I want to develop a practical case that is a linear regression analysis to measure what's the impact of X variable into Y variable. And in other words, to be more concise, is for each 1 unit increase on X variable, how much does the Y increase? For example, from some analysis that I have been doing between inflation and CPI and the mortgage rates, which is the data you see here, we reached the conclusion that for each 1 unit increase in the inflation, 1 percentage point, the mortgage rates increases 1.57. So these are the type of conclusions that we can reach by developing the techniques that you will learn today. We will discuss with ChatGPT as well because it can have some prior knowledge of which are cool indicators to make a practical case upon, and then we'll drive the session through there. But please feel free to drop any questions in the comments that I will take them as a priority. Now, for the inputs. So the input will be indicators from the Federal Reserve. And for the steps, so we will have to probably download the data. Second, we have to load in Python. Then we will have to join them in the same table and build the linear regression analysis. All right, so let's just get started with the first thing. I'm gonna use ChatGPT, which is in here. All right, I can take it here. And I will ask I'm gonna build a practical case analyzing information from the Federal Reserve, whose acronym is FRED, following the following plan, the plan. And the plan is the same thing that I have here. So I just paste it in the code. I ask to the chat and let's see what we get. Okay, we get some code to download the information. Load in Python, then develop the regression analysis. Okay, I will go step by step because otherwise you're not gonna learn anything, and you will learn because of this step by step teaching what's going on inside. More than having this already constructed practical case with indicators, I'm gonna ask for some proposals. So there are many indicators in threads. Which practical cases are great to prove a point through a linear regression analysis? Okay, unemployment, inflation. Okay, so higher unemployment often links to lower inflation. So if people, yeah, because there is not, I mean, since there are not many people working as before, there is not higher purchasing power, which means that people want be buying a lot of things, and that's why the inflation would keep at a lower rate. Can be a good case. Let's do it to see which is the measure, because the most important thing is to conclude for each 1 unit increase or decrease in the unemployment rate, how much does the inflation increases or decreases? Those are the type of questions that this analysis will address. Okay, so I get unrates and CPI AUCSL. Let's see how we can download them. ChatGPT already knows how this is built in the official website. So I'll go to the Federal Reserve, click on the search, go for the unrate, which is unemployment rate. And here we get the chart. Now, if I want to download this information in a raw Excel file, I can do it through here. There I have it. And now I visualize the Excel by clicking in the downloads. And there I have it. We've got two sheets. One is a readme of the information, and another is of the monthly information. So the question here is how we can load this data into Python. Let's go to Visual Studio, and now from the downloads folder, we can search for the unrate, and then drag and drop. In here. Now, to better organize the information, I always advise that you create a folder for the data, another folder for the notebooks, which is the Python code, and then you move them here and the data here. Now, in our script, what we shall do is, first thing, to load the data. For that, we need to reference it. So I create a variable called the path. I try to execute, which I can do by pressing the play button here. And then for telling the path is the location of the file. So we have it in unrates inside the data folder. We have to go from the notebook folder one backup so that we are in the roots. I go to there with the two dots, and then we see data and unrate. Now, to load this data, we must use the library where the functions for working with data tables are, and that is pandas. So we import pandas as PD, and then we access the functions through the dot notation with reads Excel. We go to pass the IO, which is a parameter asking for input outputs the file, and we have it in path variable. We execute, and there we get the information. However, this is not the one that I want, because that's the metadata, which was in the second sheet, in the first sheet of the Excel. I want the second. So how can I pass the second sheet? I access the properties of the function in the Excel to see if there is a parameter that I can use to load the second sheet. And here I get one parameter called sheet name that by default is 0, which means I am loading the first sheet. Python starts counting from 0. And I will put the 1. So shed name equals 1, and there we get the information of the unemployment rate. Now, there are many things to do. What I always advise is to create a chart so that you can visualize the information through a chart rather than observing the numbers. To do so, we can import the Plotly library, which makes the charts to be interactive, and then go to the scatter plot. If we had two numerical variables and we want to plot dots. However, this is a time series that it's usually plots through a line or through an area chart. In our case, let's go with the line. The function is asking for data frame X and Y. We can put it here. And then for the data frame, we pass the table. Data frame is the name that we relate to the tables in Python. df, where we have the information. Go here, df, and now we go to the x to pass the observation dates in the x-axis and in the y and rates. And here we get the time series, which is a bit big. Let me change this by default and put the width to be 500 and the height to be 400. Let me put it. Okay, there we have it. And this is the same information that we had observed earlier in the official website from the Federal Reserve. The same data. Now, let's go to the second indicator, which is the CPI inflation year-on-year change. Go here, search again for another indicator. This is consumer price index for all urban consumers. So there we have it. Maybe there is some variation inside. The data is monthly. Let's see if there is some. The good thing about the code is that if we develop this practical case and we find no relationship, since we can search to any other indicator, we can replicate the same process with other practical cases, but we don't need to redo the code again because it follows the same structure. Let's download the Excel, do the same in the codes by dragging and drop the file in the folder. Now, here, what I can do is I copy the same codes. Let me organize it. There is a trick in Visual Studio so that you can organize the codes. You have outline, and here I will put, for example, the plan at the beginning. I will put the to hash so that it's a heading, and here we have it. Now for the context, I do the same, the outputs, the inputs, and the steps. And there we have a better structure for the outline. And I will follow with load data. And first we have the unemployment rate that I can put here. Now, if I want to make an indentation because it's a soft section of load data, I can use it here with 3, and above I have the 2 hashes for the second level heading. All right, so now I copy these cells of code because the only thing that I need to change is the name of the file here, and I will do it by selecting with Shift and down the cells. I copy with C, and then I paste below using V. Now, we change these names to be CPI, UCSL, and then here we do the same. There we have the information, and I plotted, but I went too fast because the column that we had defined in the plots, we put unrate, but that was in the previous data set. Now we are working with the new indicator, which is the CPI AUCSL. Let's define it here. And there we go. All right. So now the problem is, how can I join these two tables? So the first thing is that when declaring the variable, we must use different names. So for the first one, I will use at the end, I will create it, and I will put unrate equals to df, and I create a copy because up until this moment, the data frame is the one about the unemployment rate. I can go here, and then I do the same for the CPI. And I will put df CPI. All right. Now, how can I join these two tables? So I have the CPI from one side, and I have the unemployment rate on another. A cool thing is that these two indicators are registered on a weekly basis, on a monthly basis. So this is good because there won't be any problems. Later on, we'll work on another practical case that might have that problem. And the function to join the data is inside the pandas library, which is the one dedicated to data tables. I go with the dots and search for the function that I have already told you. So it's join. If I, they got me. It's not join. It's a strange concat is the function. And if you don't know how to work with these functions, etc., you can always ask ChatGPT. Like you go here, how to join two indicators in the same table. It will tell you the concat function that you have here. So I won't pay too much attention explaining some of the things that I already know. I will go directly, but just so you know, you can always ask the ChatGPT which is the function for that or for the other thing. Now, in the concat, we have got the first parameter to be objects. So the first parameter is the thing inside the brackets, and they are separated by comma, one per line. And they say an iterable of series or data frames. In our case, if it's an iterable, it means that we have got to put the square brackets. Now, inside the square brackets, we must put the data frames, and they are the ones in df and rates and df CPI. So we put both of them here, CPI and rates, and there we have them. Now, there is a problem because if I see all of the numbers, I can see that there is a lot of missing data on the unemployment rates, despite that the unemployment rate was also monthly. So there should be some equivalent for this month into the unemployment rate. Why is this happening? Because right now, the concatenation is being done vertically. This means that one data set is put below the other one. How can we make it so that when they coincide on the observation date, there is the overlapping? To do so, at first, we must do the concatenation horizontally, which is axis equals 1, and now we are concatenating horizontally. However, it's repeating this observation date. To avoid this, we must define in the concat function which are the coincidental columns that we have in this data frame. So let me see in the examples at the end. There you see, but columns. Yeah, here's gonna be a bit tricky. So instead of the concat, because the concat would assume that the structure of the table is the same, we will use the merge, which is the same, but this time allows us to specify the column that is coincidental in both of the data frames. And this is the left on and right on, or on as well, if the name of the column in both data frames is the same, which in our case it is, because we have got observation date in one table and in the other. So we will use observation date. If we go on the merge, we see that there is no axis parameter, so we can remove it, and we will use on to be observation date. Now we execute, we get an error because of objects. If I go to the merge, I see that they are not asking for objects, they are asking for left and right. So I go here and I put left to be equal to one data frame and right to be equals to the other data frame. And finally, we got it. Now, let's put this in a same variable that we will call data frame. And yeah, it's working okay. And now we will do the visualization. Now, if I plot it, which I can from the data frame, they tell me an error, because if I go down below, Plotly cannot process wide form data with columns of different type. What do they mean by the different type? If I go here and I have this data frame, the observation date is of type datetime. So it doesn't have an equal treatment as plotting this information, the CPI and unemployment rate, which are floats, numbers. To make this work, we have to establish, and this is a best practice for working with time series data, as the index. The index is the column in the left, which is not really a column. The one you see here with the numbers 0, 1 is the index, and it has special properties. So we must set the index to be the column observation date. And now, because of this, we save it back into the data frame. When we ask again for the D types, we don't get, as before, the observation date, because it isn't treated anymore as a column. It's treated as an index. And now, because of this, we go to the plots, and voila, we have got the same visualization for the table. But let me change this by default because let me ask ChatGPT how to establish plotly width and height by default in Python. And the thing is that right now when I plot the information, I have this many width and height of the chart that is not comfortable for you to see. So I will use this code. I think the one that I am using is plotly dark. So I think that because I have this increase, I need to put it even lower. So let's go with 600 and 400. There we go. All right. Now, more problems that we have in this visualization. It turns out that the magnitudes of the variables, the scale, for the unemployment rate is around 5.7, but for the CPI, it's 181. If we go back to the Federal Reserve, we see that the units of the CPI, they say the index is from the year 82, 84, which was at the time, however, the CPI was at 100. And from that point onwards, they start counting. So the inflation here is 177% because there has been an increase on the inflation of 77% with respect to the year 84. And this is how we can interpret the rest of the chart. So in other words, what at the beginning of the year 2001 was, no, which was at 84, costed 100 euros. Nowadays, it costs 193 euros. So that's the, if before you could buy, for example, one car with a type of car of 100,000 euros, nowadays you would need for the same car 193,000 euros. All right, so how can we go back and visualize this information properly? We need to have different plots for these two data columns. So there is a property in the plotly library that is called facet col. And we can use variable, and there we have the visualization for both of them. However, we keep having the different y-axis. To fix it, we save it into the variable figure and now update the y-axis so that the axis doesn't match. Matches equals none. And finally, there we have the information. Well, this is quite an increase. The year. What's happened in the US in the year May until November, December? What's happened in the US from during 2021 so that the inflation increased from 4.2 until 5.7. The good thing about the chat is that it knows everything. Can go online and search the information. Ah, sorry, I misspelled 2021. I meant 2001. Here they mention that there is a study, for example, of the Federal Reserve. Let's check it out. Let's see if we can account for something of the year 2001. Okay, nothing. Anyway, I won't research it. Leave it for later on. Now, what shall I do if I want to make an analysis of these two indicators? If I ask to the ChatGPT, this is already the linear regression. Let's create the heading. And now to the ChatGPT, I will say, all right, I have chosen this case. I have the data in Python already joined from the year 2001. And a good practice is to copy the data frame because so that the ChatGPT has an understanding of what they have. So I will go to clipboard. Now I have it here and I can paste it in the chat. I pass it. All right. Here they told me how to develop the time series, and this is what they told, but they had to do a pre-processing. You see here that they had to put it the inflation year on year. But yeah, that's because the this the CPI, I think it was an index. Why are you transforming the CPI? Yeah, you see, the CPI, it's an index level series. So they are counter effect in that and using the year-on-year inflation so that it can be relatable to the unemployment rate. So let's go back. And here we apply the same code. Data frame. I don't like to put different names. If I already chose this one, I will keep using it. So there we have it. And now because of this change that's been year on year, I will plot the information again using the same function as before. Let me put this into a function so that we don't need to repeat this. Def plot df, and it receives the data frame and finally returns the data frame with the access. Return the figure. Let me increase the width. All right. So now we see a different pattern on the CPI. Now it's more relatable to the unemployment rate. We have more ups and downs. That can be the counter effect because you see that as the CPI goes up, the inflation unemployment rate is going down. Let me plot this row by row so that we can observe better the information. So instead of using the call, I will use the row, and there we have it. Yeah, I mean, here we see that the here is going up, down, but at the end here, if it's going down, the CPI goes up. Let's see how that relates on the measure, because we could establish that for each 1 unit increase on the CPI, the unemployment rate could increase X time or the other way around. Let's check on the practical case, which is this one. Okay. So if I want to develop the linear regression, which I can put here the formula by using the LaTeX inline formulas, and I can tell here that the variable that I want to predict is the inflation year on year. So CPI will be equal to the unemployment rates multiplying one number plus another number, which is the constant. And the epsilon here, let's remove it. Not really needed. Okay. Now, regarding the rest, we have to develop the linear regression, and this is inside the stats model library. Let me go there, stats models. We go to the submodule API and import everything as SM. So API as SM. I have to put here the import. And now SM, we go to OLS, which is the acronym for ordinary least squares. In other words, the linear regression is a synonym. And now they are asking for endogenous and exogenous. This is endogenous, the variable y, which is the one we want to predict, in this case is the CPI that we have in the formula. So we want to know how much the inflation goes up or down based on if the unemployment rate went up or down, which, recapitulating with the hypothesis of the initial of this streaming, was if there are more unemployment rates, there is not more purchasing power, so there won't be capacity to push up the prices. But we want to measure that effect. So the Y, we can have it from the data frame, which is CPI year on year, save it into the variable Y, and there we go. Now for the other variable, which is the exogenous, we have the unemployment rate. We save it into a variable that we will call X, and then we go here and execute. There is a thing that we must do in this case. I'll show you later because there is a reasoning on the formula. So these are the results, the model. But for the model, if I want to see the results, I will use the function summary, but I cannot access it because the numbers haven't been computed. To do so, we apply the fit, we go to the model, and now we check for the summary, and here we get the numbers. But there is a problem because we are getting missing data, not the number. Why is that happening? Because in the data frame that we were using, there is missing data here. This missing data should have been dropped. So we use the function drop, but we get an error. Drop NA, missing data. We save it back into the variable, df. Now we don't have any missing data, but the year starts in 2002. We execute everything again, and now we get the results. Very quickly, we get here the number unemployment rate 0.16416. What is the meaning of this? That for each 1 unit increase on the unemployment rate, the inflation, since it's being multiplied by a number below 1, decreases. Because if you have 100 and you multiply it by 0.7, you get 70, which is 100%, you get 70%. It's like a discount. And the measure would be that for each 1% increase in the unemployment rate, we get a decrease in the inflation of the contrary, 1 minus this number of the coefficient, which would be around 60%. That's quite a lot. Let's check with the ChatGPT if I get this coefficient, how to interpret. Okay, the target variable was CPI year on year. Does it goes down 1 minus this? Ah, okay. Okay. Ah, yeah, that's true. Yeah, I was wrong. The number should have been negative. Forget what I have just told you. I mixed up with the logarithmic regression. So the real interpretation would be, let me showcase it to you to prove it. In the model, we get a function because we have already computed the numbers of the mathematical equation. These numbers of the mathematical equation are 0.4, that if we go here, we get put dot. We get this minus 0.4. The 7.27 it's missing from these results in the table. There is not a constant because in this library we must add to the x variable a constant, which is 1 when passing it to the data. To do so, we use sm, add constants to the x, and there we get the result. So we save it back into the variable, and we do that before importing the library, because otherwise when I execute again, I would get an error. So if I reference sm here, it must be defined above. I execute, now I get the constant, and finally I get the negative value. That was the point of this relationship. So let's copy these two numbers and put them in the mathematical equation. Let's put them here and here. All right, so now the meaning, now it's more logical that for each 1 unit increase in the unemployment rate, the CPI year on year goes down 1.16. How can we prove this? So, for example, if I go to the model, we have a function to calculate a prediction. If I pass a number from the exogenous variable that can be, for example, 1, let me check the error. You see in the error here that they say shapes doesn't align with the data, 2 dimensions, blah, blah, blah. This is because the data must be done through a double quotes, double brackets, because we passed a data frame and also the inflation, the constant that we added. So we get 7.86, which is the result of, let me go back, bring this down. So if I subtract to the number 9.02, the multiplication of unemployment rate equals 1, because this is the one that I am passing. Multiplied to minus 1.16, I get this number, 7.86. Now, if I multiply for the 1 unit increase, which is 2, I get this other number. And if I multiply by 3, I get this other. So what is the relationship here? That if I copy this and I subtract it, the increase or decrease, how much is it? Minus 1.16, which is precisely the coefficient that we've got here. And this increase or decrease remains the same for each 1 unit increase on the y-axis. So if I go from 1 to 2, I get minus 1.16. And if I go from 2 to 3, which is 1 unit increase, I will get the same. There you see it. But if I go 2 units to the right, which is on the increasing on the unemployment rate, I get double from 1 to 3. And this is how we can interpret the results. Model, summary, there we see it. And now that we've got these results, let's pass it to Python. Also, there is a trick that you can use to visualize the information, and this is if you develop a plot with a scatter, you put on the x-axis the unemployment rates, and on the y-axis you put the CPI year on year. There you see the points, and if you put trend line equals OLSS, there you get the same mathematical equation that we saw earlier. But this model is not quite good because you see the R squared, which is 0.7. It means that there is a lot of error. Like our model can only explain 27% of the variation that the CPI really has. So in this case, we need to come up with a different solution because the R squared, which is here, is telling us that our model is 27% good. How can we solve this? Looking at the data set, if we go at the beginning in the data frame, here we observe that it only goes from the year 2002 until 2005. What happened? Let's check it out on the real data. Yeah, because the CPI here, it's only up until May 2005. So failure. We cannot only visualize the information from there to here. But since this is Python code and we can replicate into other practical cases, we can simply go to the notebook, create a copy and paste. Now we go to the second and we use unrates, CPI, and other. Let's move it down below and then we execute again. And this time we must look for a CPI that is updated and until nowadays. So let's tell to the chat that I can even create a screenshot. I copy here the indicator you told me. This is why the AI is not going to solve all of us and it's not going to take all of our jobs. It always needs some technical guidance on the data that is messy. You told me that the CPI is not updated, only until 2005. Which other can I use from threats? That is CPI. There are many inflation indicators in the Federal Reserve, so we just asked for one of them. I will pass the image to the chat so that it can have more information what I meant. If you have any questions, like feel free to drop them in the comments. Don't be embarrassed. I always say that there are no fools for asking stupid questions. There are fools because they don't ask questions. So do it if you have any. That I'm pretty sure with this all Python going back and forth, maybe you haven't started writing Python code and want some tips. Let me know the questions and I'll show you with my best. All right, so here we got another one, and they say CPI UCNS. Let's check it out. Okay, this is good. We got until nowadays. So we download again, Excel, go back to Visual Studio, drag and drop. And the only thing that I need to substitute is the beginning, the CPI UCSL by this other. And you see that we've got here a button to modify them in all locations. So there we go. Now, if I execute everything again, there shouldn't be any error. Let's see. Good, 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 good. This is the magic of the codes and not the Excel, is that because you have built a practical case with the code, you just change the variable, replicate and everything, execute, and you get a working solution from one template notebook instead of having the cells all around and have to change the order, etc., which is a bit messy and the problems of the Excel. Then we get something else. Okay, now this is quite messy. The R squared, which we see here, is 0.006, which is like our model is good, 0.6%, 60%. Awful. So I like to remember one of the things that my professor told me in the university, and is that mm, you can torture the data until it tells you the result that you want. So we'll just do that because we can transform, aggregate the data. Right now it's monthly. Maybe we can do something or filter it out, because there is a practical case in which I'll show you in a bit. This is another of my websites where I have some other articles. And if you go to economy, discretizing time to improve econometric analysis. So this is a case study of the inflation and the mortgage rate. You see that the lines follow the trajectory of each one of the plots, but this is because the data has been segmented to be working through periods, because if there wasn't any periods, we would get a line that is crossing overall data. And this R squared is 0.28, which is awful as well. But if we torture the data by first aggregating the data monthly, here we get a lower R squared, which is a higher R squared, which is 33%. But there are many things that we can do, because if we discretize the data by creating a new column that says before the crisis, during the crisis, and after the crisis, here we get the R square, which is resulting in, as you can see in these results, between 62% and 93%, so which is quite good. So I will ask the chat if we can torture the data. Let me check here. I got very poor results. What can I do to improve it? Another cool thing is that I can directly pass the dataset to the chat and make it have everything. So we'll just do that. Let's pass, for example, to CSV, and then put data, CSV, the folder data. Let's put pre-process threads, pre-process. There we have it. We open in the Finder. And now in the chat, I will pass it. And the chat could do something to analyze it and give us the results. So let's see. Ah, okay, because that's a long periods of time, 76 years. Apparently, this type of analysis, CPI and unemployment, it's called the Phillips curve model, and they are talking about lagged inflation, which is the autocorrelation with the previous uh, data points and the employment gap. So we can just do that. All right, let's do it. And also they mentioned that there was a problem with the periods, which was 76 years. So let's do a filter for the date range so that we can achieve proper analysis conclusions. Now here they are doing the same thing that I did in the, which is segmenting. So let's give it a try. There is a function that I can use, which is called cut, to produce this type of column. let's use the function pdcat to produce the categorical column. There we go. Data frame, the decades, grades, and now we can simply drop missing data as well. They say that we can loop the regressions by decades, but let's go directly with the data frame that we had earlier, the function with the OLS, which is here. And we go to pdcat. The only thing that I need to do here is to create so that it can distinguish the periods, the facets row, what we had earlier, to be the decades. Now let's use better the facet call so that we see it by columns, and then we facets call graph to see 3 charts per column. And finally, we save it into a figure. We apply the updates y-axis, matches none. We do the same for the y-axis. Let's increase width to be 100. Okay, to be 600. All right. Cool. So here we see some improvements, it seems, in some decades, not all. For example, the 60s, we get an R squared of 64%, which is quite good. And the relationship here is as the unemployment rate goes to the right, increases, the inflation goes down. And that didn't happen during the year, during the 70s, but this is quite bad because the model is even with an R squared of 1%, which is quite bad. During the 80s, we get the same, a very poor R squared. Let's do something because I can get the results from this table by using the plotly express. I think I already had it. Gets trendline results from this figure. And then I get the results. Let's save them to a variable. I mean, when we have a categorical variable, what we do is one different line, one different regression for each period. And here I need to iterate over each one of the results. The rows, and I will print the, let me first put the index on the decades. And we print the y and the x, print x. But we want to get the summary too. Let me check what is x. We need to access the px fit results. and then later we get the summary. All right. Now we copy the outputs, and now the chat will tell us what we can improve from these results. So these are the results. What can we improve? Yeah, you see that the Phillips curve resurface in the 2000s. Yeah, because there is a thing of the economists that, sorry for in advance, but sometimes they say that they make these metrics that they call the names of the conceiver, we could say, of the relationship. But those relationships are usually occurring during a particular period of time, because the patterns that were in the 2000s aren't the same that they are in the 20s or the 70s, and that's why we see these differences on the data. There is one thing that they tell us, that we can fix it using the lag inflation, also using some parameters. So give me all the codes for the improvements. And the ChatGPT, if you know how to use it, because you have deep knowledge of the programming and also the economy in this case, the topic, and you know how to reason it, like it gives you the code. I've worked for many PhDs asking me to help them with their analysis, and I sometimes I tell them, because instead of hiring me for one session and then another session to explain these things as step by step, sometimes it's more useful because there is a lot of trial and error that they talk it out with the chat. I teach them the basic commands so that they can run the code, and then they get the results. And this is what they get. Let me, because yeah, this is a little bit messy. It needs one more improvement on one variable, not all that many. Probably what I will do is the regression. Unemployment gap. Because they say, how far is the unemployment for their natural rate? Let's search for this variable. I copy and paste the notebook so that we can have a reference for what happened earlier. 3. And now what we will do in the unemployment rate, let's go with the formula, which was the gap. Let's put here df again. Let me copy, paste below. And ROU with substitutes. Execute again. There we get it. And now to calculate the difference, we shall have the df and RO and the df and rates, but they should be on the same table. So I'm gonna just go ahead. When I join this data, I ask again to merge it, df merge, but this time I will do it with df and the df new table. There we have it, and now we have the gap. Let's put and rates gap to be equals on the difference between unemployment rates, which was the thing that ChatGPT told us, and the other. There we have it. Then we continue. And in the variable for the y, no, for the x, this time we just need to use the gap, not the normal unemployment rate. We execute everything. Now we get overall a very bad R squared, but then if we differentiate by each one of the periods, we can see some improvement sometimes. Let's check it out with the chat. But here we see, for example, 57% in one of the periods, then another 42, which is good. This is not so good. All right, how about these results now with the unemployment gap? Okay. Let's check if we can improve the analysis one more step. This was the one that I was going to, how we can have the gap and the lag inflation. So let me check. Let's do it down below. Okay, here we see the results, and the r squared. This time we must interpret the adjusted. Wow, it's improved a lot, but it's because we are relating it with the previous time. So let's check out how to plot this. Using Plotly. I prefer Plotly over Matplotlib because it's interactive. But if you were to do a paper, you would probably like to use Matplotlib. Uh, Unemployment rates gap. So this is the difference between the real data and the predicted data, which is quite good because it's almost capturing the patterns of the real data. But then if we look at the regression line, it's a bit not at all good because we are holding lag at the mean. But let me check with the chat. What's the meaning of this? Over the long run, an employment gap only weekly, like barely explains inflation, while the negative slope of the line reflects the Phillips curve idea that more slack, lower inflation. The wide scatter plot of points to improve the analysis, should I have used the periods, like the years of the decades? But yeah, that's the thing, that at different points we have the Phillips curves, in other times we don't have it. So we need to check that out. All right, so I think it's been a quite good session. I will work on this analysis on my own to present it in an article that I will publish in this website, stories.datons.ai. You can register and I'll send you an email whenever I publish these articles, which will be practical cases of the same things that we discussed during the live streamings. And also you can unsubscribe anytime whatsoever. But there are many cool things here that you will use to learn. And also if you go to the streams, you will see this session recorded in the channel. There are many others that you can watch in the channel. And in top of this, with my company, I work as a fractional solution architect. So I develop for companies structures to develop reportings or automate data processes. If you have any inquiry or how we can collaborate or how we can work on a project together, feel free to reach out. You can reach out by LinkedIn or any comment. I'll provide the contact information. Also, in datons.ai, you can click on the contact and I will answer you the email so that we can have a meeting and let's see how can we can explore a collaboration. Additionally, I have a mentor program that I can adapt the materials to your liking. So let me show you. This is the page. So if you want to work on tailored practical cases and have my guidance in real time just for you, probably in 2 months, three, like you are ready to go and develop the learnings on your own, because what I focus the most is in giving you the self-taught disciplines that I apply so that you don't waste a lot of time working in the code by yourself and you apply these best practices of working with the chat GPT, how to ask the questions. I'll give you some of the practical cases to work on things that you like, on topics, and so on. So feel free to reach out, have a session, give it a try. And yeah, I think that there are any more things. If you have some suggestions for next live events whatsoever, send me a message as well. Like I welcome them all, and I give priorities to what you tell me, so that the content that I produce is based on what you like at the beginning, and we can work it out together. The same concepts that I taught today, I am currently working on a course with LinkedIn Learning. Let me show you. Because the live sessions, you can learn them in here. You can ask me questions. But if you want to learn step by step with proper materials, you can go to LinkedIn Learning, where I have put some courses that one of them is Python for time series forecasting, which is to pre-process data. In this course, we talk about Federal Reserve data and also the Energy Information Administration. They are all explained step by step, more structured, that you can learn at your own rhythm. And I also have got another one for practical Python for algorithmic trading. This is developing trading strategies that you will test based on historical data using also machine learning so that you can predict in the future how the market will behave. But this is very tricky. So I will show you in this course above all which are the key questions so that anyone doesn't lie to you or trick you thinking that you can predict the market and become rich, because you cannot. So in this course, what I do is build a practical case that I give a solution, then that solution is an error, then I show you the solution of that in the following chapter, and so on. So by the end of the course, you know key concepts of machine learning, such as overfitting, how to backtest, how to calculate the score to see how good is a machine learning model. All of that applied to the practical cases of algorithmic trading with data from the stock market. And yeah, so take a look at these courses. Let me know how you go with them. Give me also some ideas that you'd like to explore, and I can also pitch the courses to LinkedIn Learning team and develop more content that you will like to learn from. So it's been a pleasure. I hope that you have enjoyed this live streaming session, and I'll see you around. Bye bye.